Hi, welcome back. This is part three of limits. And so we've got two more concepts to work on, and we'll be basically done with this idea. So the first one is what happens in the long run, the long term. So what's happening to the y value? Remember, this whole limit idea is about what's the y value. That's what it's all about when x's get really big. So we know where the x's are doing. They're getting big. They're getting to thousands, millions, billions, getting very, very large. What is the y value doing? So we're, almost going to infinity, not quite beyond, but we're getting really large out there. And we can go in both directions. We can go to the right, which means going to positive infinity, or we can go to the left, and that would be negative infinity. Okay, so what's happening with these puppies? Well, I've got an example here. Kind of used it before, but before I want to bring your attention. Before we did x goes to 2, but this time we are doing x goes to infinity. That means large numbers. So what happens to our y values when we start plugging in thousands in for the x, when we plug in millions for the x's? That's the idea. Is there a y value that we're getting close to? Or is this just graph, the values just getting larger in either direction of infinity or negative infinity? So that's what the question's all about. Do we level off to a number? And we're talking about big x's. So we're talking to the right side of the graph. Don't care about what happens near the axes. We're caring about way out here to the left hand side. So I drew this graph right here. So this function, I drew it. And so I'm looking at way over here to the right. Do not care about over here and near the vertical axes because we're talking big x's. So we're talking to the far to the right or far to the left if we're going to negative infinity. And so this graph appears to be leveling off, and it appears to be leveling off at a y value of 0. Okay, and so that's what's happening here. And this one has a limit, and the limit's going to be 0. Numerically, we can see this happen as well. I'm plugging in, as I plug in larger numbers, I plug in 10, 100, 1,000, 10,000, a million. Hey, just remember your calculator's not going to show you all 6 zeros, so it's going to do that, it's going to show you some scientific notation with an E6 kind of thing. And so what's happening to our values here? Well, they're getting smaller. They're getting close to 0. Because remember, an E negative 6 by a calculator just means move the decimal place 6 places to the left. And so this is really 0.00 with 5 zeros and then a 1, but it's a very, very small number. So these numbers are all getting smaller, getting closer to 0, and that is what's happening to there. Now, algebraically, if you wanted to do this, what you could do, the technique, the theory behind this, or the theoretical aspect, or the precise way I have to do this, I have to find out who's the largest term. In this case, between 2x, x squared, and 4, x squared is basically the largest term. So technically what I want to do is divide everybody by x squared and then analyze it. But I'm going to basically say we can do it another way. We can kind of just rationally do it. So when I look at this, I'm looking at who's the dominant power. And what I'm seeing here is the power 2's in the denominator. It's a power 1 on top. And so that means the denominator has the bigger power. And so when you start plugging in millions, the denominator is going to be so much bigger than the numerator that it's going to dominate. And whenever the denominator of a fraction is very, very large compared to the numerator, the top, when the bottom's large, your overall value of the fraction goes to 0. Now, if you switch that and the top has the higher power, then you're going to infinity. And if your powers are the same, then you're going to level off to a particular number, okay, a number different than 0. So what we're looking at here is we're looking at this thing is leveling off to 0 because of our higher power in the denominator. And so that's kind of what we're looking here. That's what we're playing with. And that's our long-term idea. Our next idea that we have is with limits, we have to be concerned about left versus right. That's when the two sides of a limit. You see here at negative 3, on the right-hand side, this graph is going off to infinity. So whoops, excuse me, I did this backwards. So I want to start from the left-hand side. So notice this little negative sign right there. See, it's -3, and then I got a negative sign in the power place. Whenever I see that, that means I'm coming to -3. -3 is the number we're getting close to, but we're coming it from the negative side, from the left side. What is the y value doing when we get close to -3x? And then what's the y value doing? This graph on the left-hand side from the negative side is going to negative infinity. And then we have another way of doing this is like this little plus sign right here. That's coming from the right side, coming from the positive axis side. As I come from the positive side, as I get close to -3, what's the y value doing? This puppy's zooming off to positive infinity. So I'm coming from the right, from the positive side. The y values are going to positive infinity. Okay, now we've just done the left and right limits. So coming from the left side is our left limit. Coming from the positive side is coming from the right side is our right limit. Notice these numbers, well, they're not numbers to begin with, they're infinities, but also they're not even the same infinity. So basically one's negative infinity, the other one's positive infinity. That's just messed up. And so when things are messed up so bad like that, we basically say that the limit does not exist. Okay, so D and E, the limit at -3 does not exist because the left and right side don't agree. It's kind of like a bad marriage in a way. Whoa, it's kind of like Brad and Jolene. They're just having a bad time. So their marriage does not exist anymore or will not in the future. And so that's the same idea. We've got limits. When the left side and the right side don't agree, then we can't have a limit. Whether it's infinity or nice numbers, if they don't have the same numbers, then we say does not exist. Okay, so let's talk about our key points. So when we use limits, they're really helpful, useful when things are not working. When we've got dividing by zero, we got breaks in graphs. That's when limits work really great. And the other thing is for long runs, because how are you going to plug infinity into your formula? Infinity is not even a number, it's a concept. And so you can't even plug that into the formula. So that's another reason why limits work really great for us. Okay, so limits, the thing I want you to know is that we know the x. We know what the x is doing. That's what's shown here, listed in that little part of the limit idea. It's the y value, that's what we want to find. So just keep that in mind. It's all about the y value because we already know the x value. Okay, this ends part 3. I've got part 4. I just got some graphical example that I just want to throw to show you. And so that's the limit idea on a very kind of introductory, superficial level without getting really into the details and the theory. Thanks and have